Hey, Yosin. Hello, everybody. How we doing? Absolutely fantastic day today. Hello, everybody. Woohoo! How we doing, everybody? Hopefully we're doing fan-diggy-antastic of this absolute glorious morning and afternoon. Great to see everybody here. Look at all this positive vibes, ladies and gentlemen. Positive vibes. I love it. 100 positive vibes. Hey, Lysirena, good morning / afternoon. Brian, good morning / afternoon to ya. Good to see you all. Yosin, I hope you're doing absolutely fantastic today. Glad you could make it out here once again to this stream. Thank you so much here. Khadija says, yeah, no, should have been like this from the start, but it's super drain. Really want to get an A in this class. Still hard to find the focus and time to sit down and do work, I understand. I'm really trying, and after I get back from the DMV today, I'm going to force myself and just binge the homework and maybe, okay. Alright. I want to see that consistent progress. Look, you got a lot of love, you got a lot of support. Now we want to see you follow through. Like I said, this is not just a class, this is a matter of growth. And I think that we're trying to find out, find that growth, and I think that's incredibly important. So Nicholas, hello, good morning / afternoon. Look, I'm all for personal growth, and I'm all to hopefully foster that personal growth. Sometimes it just takes a little nudge in the right direction. Gemma, how we doing? I didn't have to redeem to say something nice. Yes, indeed. Thank you, Jess. Yeah, we could do this. Look, that's why I say first day. You all are adults. You all take accountability for yourselves. But this is where you start to, actually, I guess, show what the difference is between a kid and an adult is. Some people will get this point, some people don't. But I would have to be confident. I'd have to be confident that the people who come to this stream want to be better people. And like I said, I'm happy to oblige in that regard. That's why coming out to the live streams here are really unique and special. You don't get that when you just watch a replay. You get that when you come and you sit down and you talk with me, and I will certainly tell you real time how it's going. Bernice, hello, good morning / afternoon. Hopefully you're doing absolutely fantastic here today. Hopefully you're doing great today. Hopefully it's all chill today with you, Bernice. Got look at all these fantastic people here today. We've got 11 people on the stream. You know what? It doesn't matter how many people are on the stream. The only thing that matters is people who come out, want to be better, want to do good, want to get that grade. There you go. Gemma, it's the evening. I know it's the evening for you. But Gemma, you come out here, you say, hey, I want to sit here, I want to chill, I want to talk with Chibs, because, well, hopefully Chibs is a cool dude, I don't know. I have to look at myself in the mirror again. Anyway, but, hopefully you have a sit here, chill, have a nice time, it's always good. This is actually my second time taking Math 112, but I feel a lot better about it this year. That's good. Look, there are times where I've had people take this class again, even with me, take it a second time with me, and And I tell them the same thing that I've told you, Khadija, and that's the same thing that I tell everybody else. This is kind of like I give you full purchase to do whatever you want. And it's like, okay, you could do whatever you want, however you want, whatever pace that you want. I said, here you go. It is what it is. And it's up to you to go ahead and fulfill the expectations. But again, it's not, again, I don't want to give a grade that's bad. I don't want to give bad grades. I hate giving bad grades, okay? Mind you, it's just not the best feeling in the wide world. I want to give you a great grade that you earned yourself. And again, that's part of, for me, is like, that's part of the kind of the, hey, I got to take responsibility for myself. I got to put forth the effort. I got to put forth the time. And I will definitely give you the grade you deserve for the amount of work that you put in and effort that you put in. No problem. And a lot of people, when they hear that, they're like, you know what? I gotta, you know, that's kind of like the, hey, you gotta come to Jesus moment, if you want to call it that. Be like, you know what? I gotta do it. You know, I gotta grow up. I gotta stand up. I gotta do the adulting thing, and I gotta take care of my crap. You know, or I should say, take care of my shit. You know, if I'm gonna be as colorful as possible. And there you go. Sink or swim is not so much as like you fail or pass. It's more along the lines of you grow. You either grow or you decide for yourself in this class. In this class, you either decide for yourself you want to be better, or you decide for yourself you want to remain the same and still remain frustrated. I'm going to just tell you that right now, Brian. That's the decision you want to make. Like, I don't even need to tell you that, Brian, that as a police officer, that's kind of like the decisions that you got. Basically, you have to basically tell some people either you want to go down a certain path and this is going to be the consequences, or you could go down this path and better yourself and be a better citizen, or whatever the case may be. You know, as a police officer in your field, Brian, your goal is to eliminate your job entirely, or at least build up other people to be better in your communities. Gemma's got something to tell me. Tell me, Gemma. Tell me, Gemma. Tell me. I wish next year I got a professor like Jim's. Not just about how they teach, but the mindset difference impacts a lot. Look, I've been teaching in some capacity for nearly 20 years now, but my mindset has not wavered in that regard. Is that I haven't forgotten how it is to be a student. I haven't forgotten how it is to have to grow little by little. Next year you might come to America. Hell yeah. Woo! There you go. Hey. All right. Yeah, welcome. You're always welcome here in America. No problem. No problem. You coming with a family, bunch of friends? What's the story behind that? Think about it like a video game. If you grind your character, you'll be top tier in the game and be even better than people playing the game. Your character XP. Yeah, it's true. You grind yourself. Sometimes you gotta grind through it. And sometimes you gotta do things you absolutely hate. But when you get through it, you feel a whole lot more, you feel like, you feel a whole lot better for it because you learned a lot along the way. As the saying goes, sometimes it's about the journey as opposed to the destination. So, I mean, there's definitely that. That's fine. No problem. You coming with your mom? We're not gonna be near you? Oh, sad face. Well, if you do come to the Chicago area, Gemma, you're more than welcome. I'll be more than happy to show you and your mom around. Got some nice places that certainly I could recommend go to, that sort of thing. So if you decide to come out by this way at some point, know that you certainly got a tour guide to help you out. Okay, going to Florida. Hey, My cousin's family's out in Florida actually. It's a really nice area. Where in Florida? You going to Orlando? Gonna go to Disney World? Go Disney World. I've been to Orlando a few times, so mainly for weddings, but hey, it is what it is. Alright, ladies and gentlemen. Ladies and gentlemen. Prepare for at least 10 minutes of rain per day in Florida. Yeah, like out of nowhere. That's true. Yep, going to Walt Disney World. Yep. Like I said, I've been to Orlando on a few times now. Like I said, mostly for weddings, but yeah. I hope you really enjoy your time down in Walt Disney World. I hope you have a wonderful time out there. And yeah, just go. You and your mom, you go have fun, okay? Go have some fun in Disney World, okay? Everybody should go at least once. Just have a nice time. You know, I know a lot of things. Of course, everybody says a lot of things about Disney World. Yeah, I get it. But you know what? Gotta experience it at least once in your life. You know, get it out of the system. Go it all the way. There you go. I can smell what my mom made all the way to my room. Super hungry. What'd she make? Did she make some korma? Did she make some nahari? Did she make some chicken maghni? Did she make some what did she make? Biryani? She make some aloo katakari? Is that what she made there, DJ? Khadija, you gotta tell me. Chicken maghni! I was right! Ba-bam! Yes! Got it! Look at that! Woo! What's my favorite food? Wow, I have a lot of favorite foods. Man, I can't like narrow it down to one. I can't narrow it down to one favorite food. Because I've eaten a lot of different types of food. You know, I could say ramen, you know, actual Japanese ramen, but I could say, you know, of course, some pizza from Lou's. I could say, you know, Italian beef from like Portillo's. I could say a lot of different things. So if I narrowed it down to one food, it wouldn't be fair because I eat a different variety literally every day. So yeah, I can't really narrow it down. There's foods that I like, but not a favorite one. I can't really say that. Like this chocolate chip cookie I got in from KFC yesterday. But have I ever had Kichikata ramen hopping station? You betcha, buddy. Yes, I have. Yes, I have. That stuff's amazing. Have you had I have to ask, have you had Santoka? Have you had Santoka ramen in Arlington Heights? In the Mitsuwa. Yeah, so Mitsuwa is like the Japanese supermarket out in Arlington Heights on the corner of Arlington Heights Road and Algonquin. And so it's in like a food court area, right? So they got the Japanese supermarket on this side, and then they got the food court area. So it's in the food court area, and that's my favorite ramen spot right there. That's my spot right there. So I kind of already have an idea of what size differences in Paris compared to Florida. That's true. It's true. DRG Discord. DRG Discord, thank you for the follow, my friend. DRG Discord, thank you so much for the follow. I really appreciate it, my friend. Thank you so much. Thank you. I hope you're doing well, Mr. DRG. If you ever in Elk Grove, hit up Tata's Pierogi. Ooh, pierogies are good. I like pierogi. I tutor in math, so I tutor people in math, so instant follow. Hey, appreciate that, my dude. hey, look, I appreciate math tutoring. I appreciate people who do that. I appreciate people who put in the time and the effort to help as many people as they possibly can in a subject that can be dry as hell and can be very, very difficult for some. So, much love and much respect to you, DRG. 100%. Okay. So, I really appreciate what you do. I used to tutor, and when I was in graduate school, I used to tutor, and also I would teach, of course, TA classes on the side, as well as study for my master's degree. So that was pretty fun. All right. Oh, okay. It's 12:10. Okay, sorry. I gotta actually, I gotta actually do things. Okay, let me do things. Doing things, my job. I gotta do my job. Let's do some intros, and let's get started here. I like homemade food. Like homemade pasta's top tier. I would like homemade food had I had my skills basically neglected me since birth and basically burned down kitchens at a moment's notice, Jess. So, yeah, my cooking skills are bar none, as in they don't exist. All right, all right, let's do this intro here. Okay, let's get started today. Welcome back to Thursday, end of the week time today. So today, ladies and gentlemen, we're going to do chapter 5 here. We're going to start chapter 5. We're going to go from section 5.1 to 5.4, so we're going to skip a couple sections of chapter 5, 5.2 and 5.3. All right, and we're going to go ahead and hopefully knock out these two sections here. Boom and boom. Hopefully that's what we'll do today. But we'll see how far we get. Gemma, because in Florida there's 3 different theme parks, that's true. Isn't there? Because Magic Kingdom, Animal Kingdom, and the, I believe you're talking Magic Kingdom, Epcot Center, or, yeah, Epcot, right? Yeah, it's been a while since I've been down there. Animal Kingdom, yeah. I would, yeah, just, you and your mom take the whole complete package, take the whole tour. You don't get to go to Florida that often, so, yeah. Okay, so today, ladies and gentlemen, let's go to the big board. What are we going to do today? What is sections 5.1 and 5.4 talking about here today? Sections 5.1 and 5.4 are going to be talking about system of equations, okay? So section 5.1 is going to be talking about a system of linear equations, and then section 5.4 is going to be talking about a system of nonlinear equations. Oh boy, that's right. Yeah, Epcot is pretty fun. Epcot I like Epcot. Epcot was pretty fun. It's got a lot of different attractions to it. So, all right. So, let's talk about question 1, which is related to section 5.1. Okay, so number 1. What is a system of linear equations? All right. Drink around the world? Drink around the world? Wait, Brian, what? Wait, what does that mean? Drink around the world? I'm confused. Explain, Brian. Oh, at Epcot. Oh, there's a thing called Drink Around the World? Like, it has different beverages from around the world? Oh! Oh, okay. Guys, I haven't been to Epcot in, like, a long-ass time. I've been to Orlando, but I didn't go to Disney World when I went to Orlando. I went for the brown man wedding, so, by the way, which was really nice, but I'm gonna trust your guys' knowledge since your guys' knowledge is much more recent than mine. Look, the last time look, yes indeed, we had both the it was a pretty nice wedding to boot. It was a pretty nice wedding to boot, I have to say. The hotel was really nice. The venue inside the hotel was really good. Man, I'm not gonna lie. I'm not gonna lie. They had a dessert bar that was at least, and I'm not even kidding you, the dessert bar had to be at least 30 yards long. Like, I'm not even joking. It was like the super most opulent dessert bar I've ever seen in my life. Like, it was ridiculous. Yeah, look, Khadija, I ain't even kidding. Normally, you go to the dessert bar, and you get this, like, you know, small little table thing. No, this thing was like freaking, you had like the 30-yard, you had the centerpiece in the middle, you had the chai on the, like, you had chai on like two or three sides of like this room. It was crazy. Like, I've never seen like this much indulgence before. Yes! Yes! To this day, I'm never going to get to see a dessert bar to be that ridiculous. I don't even eat desserts, and I'm like, I can't really pass up a dessert looking at this bar. I can't. It was impossible. So I'm like, yeah, I'm gonna indulge myself here. Yeah, I should have taken a picture. It's true. I don't eat a lot of sweets, okay? Not a ton of sweets. So I'm not a super big sweets guy. I'm just not that kind. I'm just not made that way. But I don't eat like a ton of cake or desserts or stuff like that. I have sugar in my diet, of course, but I mean, yeah, if I eat like, I don't eat a ton of sweets. So if I feel like it, I'll go get it, but I don't get a ton of it, so it's no big deal. Look, they had chai on the side. The chai was great. They even had, okay, look, Khadija. At this wedding, they even had Kashmiri chai, okay? They even had Kashmiri chai at the wedding, okay? And if you guys have never seen Kashmiri chai, this is Kashmiri chai. They had Kashmiri chai at this wedding. Okay, that's how much, bruh. No cap, no lie. With Kashmiri chai at this wedding, okay? If you want to see Kashmiri chai, is amazing. They said that you made half a tub of cookie dough ice cream. Oh, they're pretty well off. They're pretty well off. Yeah, so it's like a pink kind of chai. It takes a long time to make, but it's like ridiculously good. You have it with like some biscuits or something. You know, it's absolute delicacy. It is really good. It is really good. Again, you could get this in select places, but to make it does take quite a while to do, so you have to get it probably from a retail place. But yeah, like chai, man. Ho. Kashmiri chai to boot. I'm like, oh, I'm done. My life, it's over. Okay. It's that same feeling I had when I was an undergrad at U of I for that year and a half I was there, in which I basically got in with this guy who owned the Chinese restaurant down the street on Green Street, and he would always shovel me extra orange beef. Yeah, it was that kind of feeling, okay? Because he knew me, I'm like, I'll give you an extra $5, just give me double, because I'm a poor college student. I'm like, hey, there you go. Respect. Alright, anyway, I gotta do some math, so aloo paratha, very good. I'm gonna have to wreck myself and give it a try, because I'm old and I can't handle milk. Okay, that's fair. You know, most Asians can't handle milk either, so they don't have the enzyme to properly process it. So, I mean, to be fair, that's usually the case. Yeah. Yeah, most Asians don't process it completely correctly. They lack the proper enzyme. Did you take a plate home? No, sadly it was all buffet. You can't take plates home. That was owned by the hotel. I'll tell you, I was super full by the time I was done, because I had like loads and loads of food. Sneak some into a purse? Wait a second here. I'm a guy. What purse am I gonna use? He just like sneak some into a purse. I'm a guy. What? Where's my purse? Explain. Explain this to me. It's a satchel. My fanny pack. I'm gonna have this little pack full of rice. I just shovel it in while I'm at home like this. Oh my god. Okay. All right. I've been going on too long. All right. Let me start this here. All right. So let's take a look at number 1 here. What is a system of linear equations? Linear equations are 2 or more equations with 2 or more linear variables. So here's an example here. All right. So we got 2x minus 3y is equal to 7, or minus x plus 2y is equal to 10. All right, so we're going to be doing 2 types of ways to solve for linear equations. We're going to be doing number 2, which is talking about substitution, and number 3, which is talking about elimination. So let's go ahead and take a look here and see how we can do both. Both of them are fairly straightforward here. However, for the section 5.4, we will need at least one or both of these methods here. Sometimes you can do it with elimination, and sometimes you can do it with substitution, depending on the situation that we're given here with nonlinear systems. And we'll look at that here once we go ahead and get to that here. Hey, Goldmash, I'm doing great. How are you, my friend? All right, so let's go to substitution here. Let's pick one. We're gonna look at an example here. We're gonna go through each step here carefully, and let's take a gander and let's do it too. Okay. Bam. All I'm imagining is taking a fanny pack, taking a fanny pack full of samosas and korma and some naan and just eating it right out of it. That's what I'm imagining. All right, I digress. Okay. So let's say I had 2 equations and 2 variables. All right, so this will be my example for this one here. All right. Let's go with 5x plus 2y is equal to 0. Let's go with x minus 3y equals 0. All right. Did you at least take a centerpiece? There's no centerpieces to be taken. They had the little goodie bag with the extra stuff in it, you know. The stuff that I didn't really care about too much, but you know. Like I come there for the food, that's it. I don't need the extra fluff. I know a lot of people like the extra fluff stuff, but I'm just lucky. Look, at the end of the day, I'm just glad I'm not the bride or groom. That's what I'm glad about. I'm not the bride or groom. I'm fine with this. Okay? All right. Because if you're the bride or groom in a brown person's wedding, you have to literally, like, you get like 5 minutes to eat your food. You barely get to eat your food, right? And then you have to take like 10,000 pictures with all a bunch of random people for like 2 to 3 hours. It is brutal. All right. In any case, let's go to step 1. Step 1 here is we're going to pick one of these 2 equations and solve for one of the variables. So we have 2 equations here. We have the first equation here, which is 5x plus 2y is equal to 0. And we have equation 2 here, which is x minus 3y is equal to 0. Okay, so here's what I'm going to have you do for me. You guys tell me which of these equations I should solve for and which variable I should solve for. Okay, again, how do you know which one to solve for? See which variable would be the easiest to solve for in any one of the 2 equations, such as if a variable was by itself, maybe that's the variable you want to solve for in that particular equation. All right, so that's kind of the trick here for step 1 is basically, let's put a note here, pick the variable that's is the easiest to solve for Hence, maybe by itself. In one of the two. All right. So the second equation and x, that is correct. Okay, good. So the second, and notice here, x is by itself, right? And so you're like, okay, I can easily just solve for that in that equation. So we're going to pick, so I'm just going to write it down here. We're going to pick equation 2. So I'm going to pick equation 2 and solve for x, all right? That's all I'm going to do. All right, so here I'm just going to take x minus 3y is equal to 0. And simply solving for x here is not too hard. Again, very straightforward here. We're just going to add by 3y to both sides. Simple, 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 simple. Now, so that's step 1. Once you have that down, let's do the next step here. All right. Okay. So step 2 here isn't too hard to figure out. Step 2 here is using the result of step 1, substitute the result into the variable in the that should say in the equation you did not use in step 1. Okay, so basically the equation we did not use in the first step here was the first equation. We picked equation 2 and solved for x. Okay, fair enough. But the equation we did not use was the first equation. So we're going to take this x is equal to 3y. And again, if you want to visualize this, again, I highly recommend to visualize it as best as possible. We're just going to underline that. We're going to go ahead and draw a big old arrow here. And we're just going to plug it into this x in equation number 1. So again, if it helps you like saying, I don't know where this needs to go in this step, just go ahead and just plop that in for, just draw an arrow where that needs to go specifically. So here I get 5 times 3y plus 2y equals 0. Okay? I remember this quite clearly. Good. Okay. Anyway, I digress. All right. Step number 3. Solve for the remaining variable. So the remaining variable here is going to be, we have 15y here plus 2y. I said, Anna, when was there ever a math class without an evil laugh? That's the question you should ask yourself. All right. So here we have 17y is equal to 0. We'll divide by 17 here, and that isn't too bad here in this case. You just imagine Mr. Burns going, excellent. Yeah, exactly. Alright, so we got y is equal to 0 here. Alright, good stuff. Okay, so we got y is equal to 0 here, no problem. Now, in step number 4, we're going to use the result of step 3 and use any one of the original 2 equations and solve for the other variable. You can also use, by the way, you can also use this guy here as well, x is equal to 3y, for example. You can use that. So you can use the original, I say usually the original 2 equations, but if you want to use this of what you found in step 1, I guess I could add that here. Or the result of step 1. And solve for the variable. So we could say here x is equal to 3 times y, and so we know that y is 0, so x is also equal to 0. Now the problems here on the homework specifically are going to ask you for an ordered pair. This I'm very aware of. So again, the ordered pair you want is you want X and you want Y. So your common ordered pair, at least for this one here, is very simple. This will be in the ordered pair of 0, 0. So most answers will ask you for an ordered pair specifically. Okay, so please be sure to put your answers as such, okay, unless it's otherwise specified. All right, so I'm just going to point that out here, so that way you're not caught unawares. All right, let's do another one. Let's do another one, baby. Yeah. Here you are, Fritz. There you go, my friend. Oh, you're talking about using the full equation. Oh, okay, sorry. I think I misread the question. All right, so let's say I used equation 1, 5x plus 2y. So if I had 5x plus 2y, we have 5 times x plus 2y, which is 2 times 0 equals 0. So here we have 5x plus 0 equals 0. We get 5x equals 0. So x is equal to 0. So this is just another way about using the full equation there, if that's what you meant for that. So. Any questions about that? Hopefully, any more questions before I move forward to the next example? Next example will be a little bit tougher than this one. This one's pretty straightforward. All right. Si de nada. 2 plus 2 is 22. I'm sad. You should be sad for that comment. Concatenation only works in computer science. That's what I'll say. 2 plus 2 is 22 only in computer science. And only if you declare 2 as a string. There you go. Ha ha. I can prove it. All right. Let's do another one. My limited knowledge of computer science from 20 years ago reminded me of that fact. Yes, 2 can be declared as a string. 2 may be a number, but you can also declare it as a string and then put it as a character. I know it's weird, but yeah, you can actually declare that. You just have to use an intermediary variable to call it 2. So, yeah. What the hell is that? Manipulation of computer languages is what that is. Okay, let's go through the steps here. Look, I can go further than this, ladies and gentlemen. Okay, I can make this bold declaration, okay? Make bold declarations, all right? Let me make this bold declaration. Here's a bold declaration. Here's my second bold declaration. Here's my third bold declaration. All right. That's my declaration right there. All right. And by the way, that is provable. As provable to show you that those are equivalent. Okay. Playing. All right. Whichever song I was playing was lit. Yeah, I was just following along. All right. Anyway, let's follow here. Step 1. You have to explain now, I hope you know. Ah, you see. I see. Well, if it helps, one of the things in mathematics that you should be aware of, and one of the things that would open up your eyes, is that I never told you what context I was working over when I talk about 1 plus 1, right? If I say 1 plus 1, we always think of the normal context of that being equal to 2. But what if I said I was talking about the context of modular arithmetic? What if I told you it was like mod 2? Okay? Basically, mod 2 here is actually basically saying, what if I just looked at the remainders as opposed to just the answers when I add up the numbers together? So basically, this is what I'm saying. If I take 1 plus 1, that indeed is equal to 2. Now, if I take 2 divided by 2, that's equal to 1, but I take basically, its remainder 0, okay, as a normal division problem. The only thing I care about is not the 1, but I only care about the 0 when I do modular arithmetic. So, in a sense, since I only care about the remainder, then 1 plus 1 is equal to 0. Same thing with 3 plus 5. If I take 3 plus 5 mod 2, it's the same deal. 3 plus 5 here is 8, but 8 divided by 2 is equal to 4, remainder 0, doing the old school division. So essentially, 3 plus 5 is equal to 0. And since they both equal the same exact thing underneath modular arithmetic, 1 plus 1 is the same as 3 plus 5. And there you go. Winner, winner, chicken dinner. So because I didn't give you extra information and context, that's exactly what happened in that instance. Thus concludes my explanation. All right, moving on. Step 1. Step 1 here. What am I going to do here? Step 1 here. Which equation am I going to use here? I think Blink also said here. Which one am I going to use here in this instance? Am I going to use the first equation or second equation? And which variable am I going to solve for? Second. Okay, so I'm going to use the second equation. And which one am I going to solve for? Link said this earlier, so I'm going to give him credit for the first answer. And y. Okay, good. All right. Good. So here we're going to have 3x minus y is equal to 11. Now be very careful about this part here. In all seriousness, this is actually need to be really careful about this. So we're going to subtract by 3x on both sides. All right, so that part here, again, not hard. Again, you're just moving stuff around. Don't forget here, a couple of important things. Number 1, you have minus y here left on the left-hand side. Don't forget about that sign that you need to bring down there. All right? Now, the next part you need to be very careful about as well. Because you have minus y here, you're going to divide by negative 1. But remember how it works here when we're dividing by that by whatever number is in front of y, in this case minus 1. You have to take that number and you have to divide it everywhere. So don't forget, because this is negative especially, sign changes are inevitably going to happen. Okay, so be very, very careful in regards to that. Make note of your sign changes and go through it very carefully. So we have 11 divided by negative 1. That's going to be negative 11. And again, this is where sign changes can happen. In this case, it does. We have minus 3 over minus 1. That becomes plus 3x. Okay? So again, we don't take those things lightly because that's where usually that cascade effect of getting it wrong will happen. It's usually at this stage right here. Okay? All right. So let's do the next part here, step number 2. We're going to underline this whole thing. All right, now we did the second equation here. So we're just going to go ahead and point it to where y is in the first equation. I'm going to plop it in right like so. So we're going to get 2x plus 5 times negative 11 plus 3x equals negative 4. Okay? This is what we have here so far. All right. Really quick here, any questions about that before we move on? Okay. All right. So, having that in our arsenal, let's go ahead and distribute the 5 here. So 5 times negative 11 is minus 55. And here we get 5 times 3, which is plus 15. X equals minus 4. Okay. We'll go ahead and just clean some stuff up here. We'll add 55 to both sides. What is that? Oh yeah, that'll come out to be. Okay. So we get 2 plus 15x, that's 17x, equals 51. Divide by 17. So here we get x is equal to exactly, very nice. Okay, so we have x is equal to 3 here for this answer, for x anyway. Okay. Now, as for the second part here, again for step 4, we just want to solve for y now that we went ahead and solved for x. So again, you can use y is equal to negative 11 plus 3x, or any one of the original 2 equations that we had to start with. Either way, you're going to get the same answer for y. So let's just use the one we have here. We have y is equal to negative 11 plus 3x. Let's just plug it in. Let's see what we get. We get negative 11 plus 3 times 3. That's going to be equal to negative 11 plus 9. So here we get y is equal to negative 2. So our final answer for this is going to be 3 comma negative 2. Okay. Easy enough. All right. All right. That's fine. Questions about that? GG for those questions. We haven't gotten to the tougher ones yet. Do we really need hard ones? Yes. I just got this from the non-copyright list. I don't know what this is. It's on repeat. I think this is Roy Knox, Blue-Eyed Demon? I don't know. Go with that. I think that's the one. I'm not really listening because I'm like trying to think about what I'm doing next. Besides, I got a volume controller on my headset that can lower the volume, but doesn't lower the volume on your end, but lowers the volume on my end. So all right, let's do the next one here, ladies and gentlemen. All right. Okay, put this on half-half. All right. So next, we're going to go ahead and do another type of way to solve for 2 equations, 2 variables. All right, and that is going to be using probably the faster of the 2 here, which is elimination. Okay, so we're going to use elimination here. Now, by far and away, this is the faster of the 2, especially for linear equations. Okay, this is the faster of the 2 ways to go ahead and solve for x and y in any given system. Now, let's go ahead and take a look at an example here. We'll follow the steps that we have over here off to our left, and we'll see exactly how we can go ahead and tackle those. All right, let's go ahead and start. Okay, let's do this here. Now, yeah, there's a couple ways. Which one do I want to do? Yeah, I want to do that one. I want to do that one first, then I want to do that one. All right. A couple of ones that I want to do specifically. Okay. Wait, you need like 60 seconds? Okay. Okay. All right. So I promise you, we'll still be in the throes of the beginning of this problem here, Blink. Okay. So elimination here again is just again a different way to approach at least these linear systems. We'll also be using elimination here in non-linear systems as well, but again, we'll be specific about where we use it. Okay. So elimination is also called in the book and in the homework. It'll also be called the addition method. So you may see that actually listed there, / addition method. I'm not a big fan of like calling it the addition method. It is appropriate in one step, but I like elimination because effectively it pretty much tells you what you're doing, which is if you see here in step number 1 is you're going to literally pick a variable to eliminate. Now, you can choose either X or Y at your leisure, okay? It doesn't matter. But which one would be easier is always the question that I get asked. Well, that's usually how you can kind of foresee in the future. In step 2, it says multiply one or both of the equations by numbers. Note that they can be different, so that the coefficients of the variable you choose are opposites of each other. Okay, so that's essentially what we want here. All right, now I want to highlight how to do this here. So Khadija has said we're going to choose X to eliminate. All right, so that's fair. All right, let's do that. All right, so let's choose X to eliminate here. I don't care which one you choose. All right, but let's choose X to eliminate. All right. If we're gonna, we have to, once we pick a variable here, we have to go down that path, okay? So you have to commit, and then you'll see exactly what we'll do here for step number 2. Okay. At the end of the day, here's what I want. I want the coefficients being the numbers in front of X here in this case, because that's the one we chose to eliminate. We want these numbers here to be opposite of each other. So we want one of those numbers to be positive, whatever, and we want one of those to be negative of that same number. Okay, that's essentially what we want. Now, if we take a look here at our original problem here has 3x and it has 6x. We're going to ignore everything else. Everything else there'll be consequences, sure, but we only care about the 3x and the 6x. We want them to be opposite of each other. And again, that's what step 2 is talking about here. It says, okay, we're going to multiply one or both the equations by some number, so I guarantee that one of them is going to be one number and the other one's going to be a different number. Okay, the opposite of that number. So what we're going to do here in step number 2 is, and as Brian has correctly pointed out, we're going to multiply that first equation by -2. That is correct. Very good, Brian. Again, you can multiply both equations by different numbers. That's perfectly fine, by the way. You can get away with that in this case. But if we multiply the first one by -2, let's see why that happens to be the case here as part of this process. Okay, so I want to go through this carefully here. The reason why it's -2 is we're going to multiply everything here by -2. Okay, doesn't matter about the y's and this. Everything's got to be multiplied by -2. So we got -2 times 3x, which is -6x, plus 14y, be very careful about the sign changes, equals -26. Don't forget, anything across from the equal sign is also multiplied by -2. Don't forget, the answers are also multiplied by -2. I'm actually gonna stress that here because that happens to be the biggest mistake people make in these problems. They only think that the left-hand side gets multiplied. No, everything gets multiplied by -2. Please be sure to make a note regarding that. Okay. That's the biggest mistake I see a lot on those problems, by the way. So, and we didn't touch the second one here because, again, let's take a look at the consequence here. The consequence is that we got -6x and we have +6x. And that's exactly what we're looking for here. We want one number, which was -6, and we want its opposite counterpart right below it, which is +6. That's what we want. Since we decided we want to eliminate the x's, that's what we want to do. Okay. All right. Now let's go to step 3 here. Step 3 is the reason why we want this to happen. Again, as Joseph has correctly stated, we're going to cancel those x's, or we eliminate those x's. So again, if we add straight down, this wipes out. And this leaves us with our remaining variable here, which is 19y is equal to -19. And we're just going to simply straight up solve for y in the simplest way possible. In the next step here, we'll just divide by 19. And finally, we get y here is equal to -1. All right. Went ahead and found y is equal to -1. Now, as for the last step here, step number 5, step 5 here is use the result of step 4 and any one of the two equations to solve for the other variable. So just like for, again, the option for substitution, you can do the same thing here. Again, you have to use one of the two equations there. Doesn't matter which equation you use, whether the first one or second one. Either way, you will get the same answer regardless. So, this type of thing makes me satisfied. Well, good. I'm glad this is a little bit easier then. So let's go ahead and use the first equation. We get 3x minus 7y equals 13. We'll go ahead and use our answer here for y. We'll just plug that in. 3x minus 7 times -1 equals 13. So we get 3x plus 7 equals 13. Go ahead and subtract 7. X equals 6, divide by 3. We get x is equal to 2. Alright, good beans. Okay, so here we have 2 comma minus 1 as our ordered pair for this particular problem. Alright. Yep. Stuff. Okay. Any questions about that? We're going to look at a couple more examples here, by the way. So by far and away, this is like one of the fastest methods to find x and y. It really doesn't require a whole lot of effort and a whole lot to do. So like, alright, that's fair. Let's do another couple here. How did you know to multiply by -2? At the end of the day, I have 3 and 6 here, okay? Again, I want them to be opposites of each other. So what number is in common between 3 and 6? What multiple, you could say? Well, it happens to be 6. And I want one of them to be negative, and I want one of them to be positive for it. So the way that I can get that to work out is if I multiply the first one here by -2. So I can ensure I have -6 on the top and +6 on the bottom. And then everything else is a consequence of me doing that. Okay. So this is the shortcut here. This is a shortcut for these linear type of problems here, yeah. I would say that would be fair, Jess. This is a much shorter method, as you can tell, comparing to substitution. But as I mentioned here before, for nonlinear systems here, we actually have to use substitution or elimination. So you may think, oh yeah, this is substitution's kind of useless. Like, oh yeah, this is kind of pointless. But no, for nonlinear systems, we'll still be using this this method of substitution. It's still useful. So it has its purpose. Let's try another one here. No, not that one. That one smells, and I don't like smelly poop. Right. Let's do that one. Want to try and make the equation similar so you can eventually subtract them to find x? I'm going to add them, by the way, not subtract them. I'm adding them there. I'm adding them there in that case, Fritz. So remember, I'm adding straight down, not subtracting. Can you put out the notes again, like half the screen? Yeah, give me just a second, Joseph. Just gonna go ahead and put this example up and show you how the notes there. Okay. Go. I just need to write this problem now. All right, so here's our example here. All right. Okay, so let's go through the steps here carefully. Just says the hydrate, you got it. Do I want to become famous? Woo! Mercy! I definitely want to become famous. I definitely want to become famous. Oh! But Jess beat me to the punch. She became famous in Jess's eyes. Nice job. Alright. Alright, so let's take a good look here at this one. Alright, we're going to pick a variable to eliminate. Which variable should we eliminate? Which variable can we eliminate here? Doesn't matter which one you choose. You can pick X or Y here. X, okay. Again, you can choose either way. Doesn't matter to me. So let's choose X to eliminate. Okay. Alright, so step 2 here, we have to multiply one or both of the equations by numbers. Again, so that the coefficients of the variable we chose, which is X, are opposite of each other. Okay. So Brian says -5 on the top and 2 on the bottom. Okay. Very good. That is correct. Okay, so if you notice here, we have 2 and 5 here, right? So a number that's in common between 2 and 5, at the very least, that we can add together to get 0 is 10. So the way Brian figures is like, okay, if one of them has to be negative, I'll make the top one negative. So I'll multiply the first one here by -5. And I'll multiply the bottom one here by 2. Like, okay, that's definitely fair. All right, so solid reasoning there on Brian's part to get that to work out appropriately. So here, if we put that together, we have -10x minus 15y equals 80, positive 80. 2 times 5, which is positive 10x. That's what we wanted. 2 times -10 minus 20y equals 2 times 30, which is 6. All right. Okay. Now at this stage here, we're going to add straight down. So again, we wanted the x's to cancel out. Regardless of how ugly it looks, what? The x's are going to cancel out. That's what we wanted because that's what we chose. We add straight down here. We're going to add straight down here as well. -15y minus 20y is -35y. Equals 80 plus 60, which is 140. Here we're going to go ahead and divide by negative 35. Solve for the next part here. And in this case here, we're going to get y is equal to minus 4. Okay, so we got a nice answer here. Not always nice answers, but in this case it is. Alright. And then finally here in step number 5, I'm going to go ahead and plug it into any one of the first original two equations. I'm going to solve for x. So let's say I chose the first one again. Let's say 2x plus 3y equals minus 16. So I have 2x minus 12 equals negative 16. Plus 12. This is a blessing after chapter 4. Yeah, this is a tad bit easier than chapter 4 in that regard. The 2x is equal to negative 4. So divide by 2. So here we get x is equal to negative 2. Alright, good. Get negative 2 comma negative 4 as Brian has appropriately put out. And that is the correct answer. That's your final answer for that. Good. Okie dokie. So far, so bueno. Alright, any questions? Any questions about that? Okay. Alright. I need to do 2 more examples from this section in particular. Met this out here. Go ahead and take a look. Alright. So the next example I'm going to do here will be a rather short example, but it does have its importance nonetheless. So something I want to point out. So, alright. Go to 3x minus 2y equals 6. Okay, so let's point this out here. Alright, I want to solve for x and y here. Okay, appropriately. Alright, let's say we chose a variable to eliminate. We'll go through this process here really quick. Let's say I chose x to eliminate. Alright, simple enough. How would I eliminate x here in this instance? Okay, so you go through the process here. You say I choose x to eliminate. Okay. So multiply negative 2 for the 3x. Okay, fine. Alright, that's fine. Alright, so we multiply the first equation here by negative 2. Now let's see what we get here. Okay? Now if we do that here for this system of equations, we get minus 6x, which is exactly what we're looking for here. We get plus 4y equals minus 12. Here we get 6x minus 4y equals 12. Alright? So by and large, this is exactly what you wanted. You wanted to eliminate x, so the x's are gone. Okay, so the x's are completely gone. Okay. So let's take a look at the y's. We have 4y minus 4y. What's that? Alright, 0. Okay. Okay, correct. It is 0. Now, I'm going to do something a little bit intentional. I know everything gets eliminated, but I'm going to do something a little bit intentional here. Now, this may seem a little bit weird, and you guys are absolutely correct. It is 0. But I'm going to do something intentional here because of an important point I want to make. So if I say 4y minus 4y, indeed is 0, but I'm going to put in here specifically, I'm going to do 0y. That's another way to write 0, okay? I can write 0y here. And I get minus 12 plus 12 here. That is also equal to 0, okay? So can anybody tell me here, what's my answer for y? What's my answer for y here in a situation like this? Y equals 0? No answer? Alright. Okay, right. Let's do a poll here for this one. Okay, I got a lot of different answers here, so poll. But for a minute. You guys vote. Tell me if it's 0, no answer, or some other answer. Undefined would be like no answer. That's true, Blink. All right, so some people said no answer, some people said 0, and then one person said some other answer. All right, let's go ahead and take a look here at what the correct answer is going to be. Now, one thing I can tell you for a certainty, and the reason why I write it this particular way, where 0y is equal to 0, is because I will get this source of confusion quite often. So, if you notice that there is one person that answered some other answer, that one person would be me. I voted for some other answer, which would make everybody else who voted incorrect. Everybody else is wrong. The answer is not no answer, and the answer is not just 0. Okay. You're probably saying, that's not fair. And I'd be like, yeah, it's not fair. But surprise, surprise. Let me guide you through the simple logic here. It's not as bad as it may seem in terms of logic, okay? Look at this carefully. It says 0y is equal to 0. That's what it says there on the screen. Now explain this to me, ladies and gentlemen. If I plug in a value in for y, I'm multiplying by 0, right? Well, 0 times what? Well, all of you were wrong, actually. I'm the only one that was right. 0 times what is equal to 0, ladies and gentlemen? 0 times what is equal to 0? Aha! Right? Literally anything. Can't I pick any number for y, and I will always get 0 back, right? Isn't 0 times anything equal to 0? Ah, there you go. Now see, this is why I wrote it down in this specific situation. I know at first it's weird, but you have the first inclination like, oh, it's always 0 or there's no answer. Like, you get that all the time. But that's why the answer is there's actually some other answer, and that is exactly correct here, Joseph. There are infinite solutions for this problem. So if you run into this situation, you will get 0y is equal to 0 or 0x is equal to 0. Regardless of which way you write it, you get infinite solutions. I quit. I quit. Hey now. So just understand the logic here. Anything you plug in for y is always going to be 0. So anything you do, you're going to satisfy that equation hands down. Now, let's say I did this same exact problem here, okay, with one minor twist. Let's say I had pretty much the same numbers here. Let's say I changed that. Does that apply if both x and y are 0? I mean, yes. In this case, yes. Yes, that is true. So if you had 0, x is equal to 0, you have infinite solutions for x. If you have 0, y is equal to 0, then you have infinite solutions for y. So if the first example there, Blink, we had x is equal to 0 and y is equal to 0 for our first example. But in that case, we didn't end up with this situation, okay? That actually was just a single solution of x equals 0 or y equals 0. Look at this situation. That is not the same. In this case, this is 0, y is equal to 0, okay? What if x didn't equal to 0? Well, how does that happen, Blink? Because we eliminated x, didn't we? So either we get infinite solutions, or we get that one solid solution. You could end up with 2, 0, 5, 0, 0, 3, whatever. Okay, that's fine. So, again, don't make a mountain out of a molehill here, okay? If you have something like, say, 5x is equal to 0, okay, then that's just straight up going to be 0, okay? That doesn't change. And then y is whatever, you know? But just look at this situation, okay? All I want you to care about here, all right, is if you end up in this situation of 0x is equal to 0 or 0y is equal to 0, then you have infinite solutions, okay? So I don't want you to confuse the two. Do the problem out just like you normally do. You run into this situation, you'll know how to approach it and attack it, okay? I don't want you to do anything different than you normally do, all right? So Jess, don't worry about it. I just want you to do the same thing, okay? And then if you encounter this, you know what it's equivalent to, okay? That's why I'm taking a step back here and be like, dude, don't do two different things for the same thing. Don't do it, okay? So if both equal 0, that's infinite, correct, Brian? Follow the process, follow the steps, you end up here, you know what you're looking at, okay? Trust the process, okay? This is a different example here, by the way, for the Lysidana. I'm doing a different example here for just a moment. So it's a similar example, okay? Oh, that's okay. So let's say I'm doing a similar example here, okay? Only I just changed the 6 to a 7. Okay, so I would do the same exact thing here, right? I would multiply this by -2. Okay, same exact process here. So again, I'm going to have -6x plus 4y. In this case here, I get -14. And here I get 6x minus 4y equals 12. All right, so I'm doing the same process here. Again, I'm eliminating x, so x is gone, just like the last example. Here I'm ended up with 0y. Now on this right-hand side, I end up with -2. Okay? I end up with a 0y here like I wrote from before, but this time I have it equal to -2. Alright, so can anybody tell me here, what's the answer to this particular problem? If I see this, where I have 0y is equal to -2, what's my answer for this problem here? Can 0 times anything equal -2? That's the question. Why would I divide by -2? I can't do that. Just follow the logic there. Just look at the problem. 0 times something equals -2. Does that even make sense? Can you find any number that's going to make that possible? The answer is no. There's no possible number you multiply by 0 that you're going to get a number other than 0, right? It doesn't matter what that number is. 0 times anything, as we just talked about, is 0. So in this case here, if you end up with a number that's not 0, like -2 or 5 or whatever, then at the end of the day, this is no solution. That's the fine line between infinite solutions and no solution. And sometimes no solution's written like this with the circle with the line through it. But that's the fine line between infinite solutions and no solution, is that number on the right-hand side. You have it equal to 0, infinite. You have it equal to some other number that's not 0, no solution. So one number can change the entirety of the problem. All right, questions? Okay. Alrighty. Let's go ahead and do a for an ant every molehill is a mountain. Now, don't denigrate yourself. You're not an ant. I just don't want you to make big deals out of something. I just want you to, again, just trust the process here. Like I've mentioned here before, just go slow, okay? Now, obviously, we're doing examples here that showcase those sort of things, but I just want you to go slow, and when you encounter something that has a particular pattern to it, you'll know how to approach it when you see it. Okay, so I don't want you to be like overwhelmed. That's how we don't overwhelm ourselves, is just basically trying to think that this thing is the hardest thing ever. So that's the last thing I would want. So I want to be sure that you're on the same page in that regard. And when you practice it, you'll be comfortable with at least knowing the general process and working on it. So that's very important there. Okay. So don't despair. It's just a matter of for some people first time viewing things, and I'm like, yeah, that's fair. First time viewing it, you need to get comfortable. So as I've said before many times, not everything for me in math came easy. So and came right away. Trust me on that. Could you ever have y is infinite solutions, x not be infinite? There are cases where that can happen. But not for linear systems. For the nonlinear systems, that can be possible. Um, but we're not going to be really looking at things like that. So, not in this case anyway. When we look at matrices, yeah, we may see an example of that. So, matrices is a little bit easier way to see that particular result. But I don't want to focus on that right now because we haven't looked at examples like that. And we're not going to be looking examples like that today. So when we encounter that blink, to be fair, I will certainly point it out and show you exactly how you could, fashion an answer in that respect. So let's just focus on the basics here first, and then we'll do something more advanced later. All right. Something I like to do in the class very often is I often like to Yeah, we're gonna be doing it in this chapter. I think so. No, not in this chapter. Next chapter, yes. This chapter, no. Posture check and hydrate. Thanks. Thank you, Blink, for the posture check. Hydration. Thank you, Gomesh. Blink, I promise you I'm not going to lead you astray. Alright? I promise you, my friend. Now, this is not the class where I'm going to lead you astray and tell you to do, turn left when you should be turning right. Okay. Let's do the next part of the handout here. Oh, right. I need to do that. In this section, that's where we encounter these nerdy type of problems. Alright. Okay. Let's do that. Well, okay. Now, the next type of problem here... Okay, continue. Do it. Okay. Okay, so the next type of problems here we're going to do is a, whatchamacallit? Going to be doing profit, revenue, and cost functions here. Okay, they're simple word problems that we will be doing here in this section. They're not very hard to do, but they actually have their real-life application that are associated with it. So, for example, here we have number. Let's do number. Let's see which one I want to do. Okay, yeah, I'm gonna do a specific one here. So, I'll type it out here on the thing and then look at it. Got half a screen there. In my janky operation, it works. All right. Okay. So let's write this problem down here. This is number 61 on page 556. Okay. So this one says a company that manufactures small canoes has a fixed cost of $18,000. Okay. It costs 20 bucks to produce each canoe. The selling price is $80 per canoe. Okay. Let's find out a few things in regards to this. Alright, first we're going to find the cost function. Find the revenue function. And then find the profit function. Find the profit function. And then find the break-even point. Okay. Alright. So, company manufactures small canoes. Fixed cost of 18 grand. It costs $20 to produce each canoe. The selling price is 80 per canoe. We need to find three functions here: cost, revenue, and profit, and the break-even point for these canoes. Now, that's what we have here for number 4 and number 5 here off to the left. We're going to go ahead and figure each one of these out here in this particular case. So the way it works here, let's talk about cost. The cost function here, as you can clearly see, is labeled here notation-wise, is C of X. Now, the way it works for cost here is that, of course, it's going to cost you money to produce each item, in this case, a small canoe. And of course, you need to produce X amount of these particular canoes. Okay? So, the cost to produce each canoe, in this case, is going to be 20. Okay? $20 per canoe. And we produce X amount of canoes. We don't know how much that's going to, how many canoes we're making. We're producing X amount. But as you can see here, as part of the cost function here, we actually add it to the fixed cost. Now, the fixed cost here being $18,000. Now, you're probably wondering, what's this fixed cost that you're referring to here? What exactly in practicality is the fixed cost? The fixed cost here is, if you think about it, Here, the best example I could ever give about fixed cost is actually using Little Caesars. Okay, now Little Caesars or McDonald's, whichever way you want to go, it doesn't matter. But Little Caesars, as you know, $5 hot and readies. Maybe you've gotten it before. Okay, maybe you like feeling, I feel like junk food. I'm gonna go get myself $5 hot and readies. That's the way to be. And you see, like, there are not as many Little Caesars everywhere, right? There's one Little Caesars. It's in like a little strip mall. You know, they have like maybe 2 chairs and a cooler, and then they got the rest of the stuff there, right? Worked there once, right? Now, one thing that you have to understand about Little Caesars is that the fixed cost before you even start opening and giving off $5 hot and readies is that you need to pay for everything else behind the scenes. So you need to pay for the equipment, you need to pay the franchise fee, you need to pay for all that stuff first before you even produce a single pizza. The franchise fee for a Little Caesars can range from 600 that from I believe it was like 600,000 to $1 million to get a franchise uh or get a franchise license from Little Caesars. It's pretty expensive. Um so you're probably wondering, yeah, that little Caesars, yeah, it does cost quite a bit to open up a franchise there, and they're very limited on how many they were willing to open. I think there's only one available that the company would like to open. I think that's in Alaska. Last I looked. It's not cheap to open up. Like, you think fast food is cheap to open up. Fast food is not cheap to open up a franchise. Okay, it is not cheap by any stretch of the imagination. A McDonald's can cost you upwards to $3 million to just have a franchising license. Okay, so that is not something that you think is, but that's part of your fixed cost before you even sell a hamburger at a Mickey D's. And so this $18,000, I'm almost sure the guy who owns them also owns the Red Wings. Yeah, well, McDonald's are franchised, so again, it depends on who owns that particular McDonald's. But when I worked at Mickey D's back in '95, I believe the guy who owned that McDonald's had owned like five other stores, 5 other McDonald's. You know who had a hard time at the start of their business? Wait, who? Wait, what? Netflix. Yeah, Netflix had a rough time at the very beginning when they were doing mailing and stuff. People didn't view it as a legitimate service until it blew up. Um, so Little Caesars is okay. So understand that Little Caesars is run by franchisees. So there's like the main corporate office, like McDonald's, corporate McDonald's, and then they give out these franchising licenses, which people open up those branches to those restaurants. Little Caesars is the same way. So they give those the people who buy those franchising licenses, they give them like the advertisements, they give them the posters, they give them like help and stuff like that. They train them to know exactly how to work the accounting and what again the recommendations for all the ingredients are going to be. So they handle all that kind of back end stuff, and the franchisees work with them in order to sell their particular product. So they almost lost their company doing the bank money. They paid back at the very last very very last moment. Yeah, it actually they almost did go bankrupt. There's also like the story for Marvel in the '90s and why they did go bankrupt and why they splintered into many different groups, selling off their characters. Marvel was so stupid in the '90s. Oh my gosh, Marvel was like the worst company in the '90s. Just absolutely dumb. Like, I don't know where they got their company sense from, but it certainly wasn't from smart people. So, like, it was a completely avoidable thing for them to almost go out. It was completely avoidable, like dead serious. Marvel didn't have to go out of business in the '90s, so they got dumb. Um, okay, so that's the cost function here. Let's go revenue here. Yeah, so Marvel in the '90s basically they're all right. To put it in other terms, let me just boil it down to a very simple synopsis. Marvel thought that their franchises were super popular, and they were, right? Biggest franchises in the 90s in Marvel was Spider-Man and the X-Men. All right, so Spider-Man and the X-Men were the two biggest titles. They had their own cartoons on like Fox, and they were like super mega popular. Everybody was reading the comic books and the whole 9 yards. The problem was, here's the biggest problem that Marvel had. Marvel had thought that, oh, that extended onto their other characters. And not only that, they thought that the amount of people who would buy the comic books because the cartoons were so popular was actually much bigger than what they thought. So they thought, okay, we're gonna have like people like 100,000 people would go buy the comic books. So what Marvel thought is, oh, 100,000 people aren't buying our comic books. We'll print 500,000. We'll print 1 million of these comic books, and they'll sell. And in reality, you only had like 50 to 100,000 actually buying it. So you have this glut of like literally, hundreds of thousands of comic books and completely wasted money. And they did that for years and years and years, and they kept hemorrhaging money like absolute craziness. And by the time that the 90s were done, they literally had no money left and were forced to sell their franchises off to other companies like Fox and the like. So, in order to stay afloat. So it was like really poor decisions to actually lead to Marvel being in the situation that they were in the 90s altogether. It should never have happened, but they decided to go down that route for whatever. I don't know who was looking at their numbers, but their numbers were bad. Their numbers were really bad. So somebody thought, let's print 500,000 Spider-Man comics or whatever. And it's like, yeah, let's do it. Like, no, let's not do it. No, you should never do it. You literally had boxes of like empty Spider-Man comics, and essentially those Spider-Man comics are like worthless because they printed so many. All right. Thank you for the hydrate chest. All right, what's the revenue for this, by the way? What's the revenue? Focus on that. What's the revenue? What is the revenue for this particular problem? Anybody tell me here? We have a cost function 20x plus 18,000. What's the revenue according to the problem? How much what's the price of again, revenue is the price of the item that I sell it to you at times the number of items sold. 80x. That's correct. Okay, so the correct answer is 80. Remember, revenue is just basically, simply put, again, how much I'm selling it to you at times how many I sold. Can't even make them rare later because Jimmy got 200 back. Yeah, it's true. It's true, Blink. It's true. They're completely worthless. They're so worthless. They're not even collector's items. They're that worthless. All right, so it's 80x, okay? So note that it's not 60. So you're thinking profit there, Josie, per canoe. But we're thinking like just revenue. How much money are we making by selling each canoe? Profit is basically taking our revenue minus our cost here. So revenue minus cost is going to be our profit function. So we take our 80x and we subtract it by our 20x plus 18,000. Okay. So if you notice here for our profit function, we distribute this minus sign to both of these, by the way. Again, that's why profit is actually really important to kind of note here, because again, that fixed cost is when you first open up a business, they say, okay, businesses usually close within the first year or two. Why? They're the the most difficult time for any small business or any regular business really, is because you're automatically assuming a loss before you even sell one product. And again, it's always the old adage, you have to spend money to make money. Okay, so because you have to spend money to make money, well, you have to have a fixed cost again before you even start picking up anything, selling it. So in this case here, that's 60x equal minus 18,000. Okay. All right. Finally, let's talk about the break-even point. Okay. Now, the break-even point is where you start turning a profit, where you actually start going into the red, which is where you're losing money, and then moving from into the red, going into the black. Okay, so that fine line between, again, that's why you call it Black Friday, by the way, because that's the most of the times when retailers go from losing money, they start making money. That's why you call it Black Friday, specifically going into the black. All right, so this is basically where revenue is equal to cost. How many of these items do I have to sell until I start actually turning a profit on my, in this case, canoes? So I'm going to have my revenue here, which is 80x, equals cost, which is 20x plus 18,000. So here I'm going to subtract by 20x on both sides. So here I get 60x equals 18,000. Divided by 60. So x is equal to 300. Okay. So it'll be 300 canoes before we start turning a profit. So we have to sell 300 of these canoes before we start turning a profit for our particular guy. All right. Okay. Any questions about cost, revenue, and profit? Starting a business at like a fast food place, you'd be surprised. It's a lot of money. Like even and you got to be careful which fast food outlet you want to go with, by the way. So that's one other thing you have to keep in mind. Like for example, a Subway is really cheap to open, right? But there are Subways literally everywhere, and really you're not going to make a lot of money at having a Subway, since there's a Subway pretty much every corner of the planet. Or heck, in the United States, I guess I should say. Not so much the planet. So you got to be careful about where you open. Location, 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 as they always say. So. Go to Hamburger University, man. Go to Hamburger U down in, where is that? Oak Park? Yeah, Hamburger University. There you go. Oak Brook. I always think of it Oak Park, but it's Oak, right? Yeah, they got one downtown. They got one in Oak. They got one downtown here on Randolph, and then no, Hamburger University is real, and it's downtown. That is actually not a joke. No, it's legit. Hamburger University's been around a long time. That's how they basically educate all their franchisees into knowing how to run the restaurant. That is a legit thing. No. Nope. Hamburger University is 100% Absolutely real. It has been around a very long time. Oh yeah, so they moved they both moved to the West Loop. Okay, so they moved from Oak Brook over to the West Loop. All right, so that's why I remember it was like in Oak Park or Oak Brook, and okay, so they just recently moved down to the West Loop. All right, now I understand. Yeah. So if you ever want to know how to run a Mickey D's, they will franchisees often will get invited to do courses with that. Couple things that you kind of have to know about Mickey D's. It's on the down low. Is that everybody knows about the 100% all beef part of Mickey D's? Does everybody know about that? We'll have to explain about 100% all beef. Now, well, like Sirena, it's not a lie. You see, it is 100% all beef. Okay, ladies and gentlemen, at Mickey D's, the beef is 100% all beef. Okay? It's true. Okay? It is 100% all beef. But 100% all beef is the supply company. Okay? 100% all beef is the supply company name. So when they say it's 100% all beef, you're not lying. It's just that the supply company name you get the burgers from is from 100% all beef. If you say it's grade A beef, then grade A beef is probably the supply company name, and why you can claim it's grade A beef. When I worked at Mickey D's, I found out really quickly. I'm like, oh, the supply company name on the box is literally written 100% all beef, and then it has like the corporate stamp next to it. And I'm like, oh, I see. I see how it is. Okay, I understand now. That's okay. I'll stick to my Wendy's spice. Ooh, Wendy's spicy nuggets. There you go. Can't go wrong with that. Yeah, it's definitely got those things. Yeah, Brian, you ain't wrong. Like the fries are only worth the fries only stay fresh for about 3 to 5 minutes. So if you want to get fresh fries at McDonald's, then order it without salt. If you want to get fresh nuggets because they can be sitting in a dehydrator for up to 8 hours, then get them fresh. Wait the 5 minutes. It's gonna be much more worth your time. If you're gonna go get a 20-piece McNugget. So I haven't eaten at a McDonald's in forever. So I'll go to every other fast food restaurant, but McDonald's is one of those restaurants I refuse to eat at anymore. So I haven't seen the video about Wendy's lemonade. Is it pretty bad? I mean, I don't get lemonade at Wendy's, so college sports players can now profit off their likeliness so that, well, that should have happened like ages ago. Because basically the NCAA and college amateurism for athletes is like akin to slavery, in my opinion. Like, it's absolutely abhorrent. It's terrible. It makes me mad. It made me it still makes me angry, like how many people got taken advantage of all for the sake of the college making money. Like like it's disgusting. Like those kids are not given the kids are not given any alternatives to make any money, and they're all doing it for the sake of the scholarship. Like, get out of here. Okay, I know what goes on behind the scenes, and so does everybody else about classes and athletes and the whole 9 yards. I've had athletes in my classes when I was at Kansas, and believe me, one of them was sitting in the front row, super nice, studied all the time, got an A in my class, earned the grade too. So I'm not saying that I passed him just for the sake of passing him. But I heard enough stories behind the scenes where I know that people just got passing grades for just showing up, because that's what you do. So, yeah, literally have no time. I'm not even joking. The guy was on the football team, right? In my class at Kansas, and I asked him what his schedule was, and literally he had like maybe 2 hours to himself. Yeah, like 2 hours to himself, because the practice was like pretty much all day. Go out to the field, practice. Whether it be hot, rainy, doesn't matter. Get home, be bushed. He's got nothing. It's crazy. It's absolutely crazy. So, yeah, definitely long over. Not everyone goes pro. Yeah, exactly. But they have to follow the schedule. They have to follow the schedule. So they got to do what you got to do. Is there class on Monday? There is no class on Monday, ladies and gentlemen. So I'm going to point that out here. There is no class on Monday, but I will point out what we're going to be doing here. We'll be doing section 5.4 on Tuesday. Excuse me. I'll be posting up the chapter 4 test this weekend. Okay, so that'll be up and ready to go. I just have to edit some questions. And then, yeah, we should be good to go moving forward. So we're in really, really good shape. We're on a good pace to get things done. We're all doing very well. All right, absolutely well. What day do you think I'll post the exam? Either today or tomorrow, Brian. One of those two. I should probably by today, more than likely, but we'll see. I got a little bit more work to do this afternoon, so. All right. Any other questions, ladies and gentlemen? Any other questions? Feel free to ask. I opened the link and saw Chick-fil-A. Wait, you won't eat a Chick-fil-A? What's wrong with Chick-fil-A? I mean, I've eaten a Chick-fil-A a handful of times. So next weekend we should be done with chapter 4 in terms of self-pace, or this weekend. Yeah, that's fair, Blink. Yeah. That's a fair thing to say, Blink. I would say that's a pretty accurate statement. Oh yes. There's one more thing I guess I do need to mention here before we end off here for today. I will be posting pseudo midterm grades as I'm required to by the college. So I'm required by the college to post midterm grades. Now, obviously, since everything in this course is pretty self-paced, I'm just going to be posting grades based on, kind of, I'll just look at it as a cursory look over your homework and test or whatever. And then I'll just put a grade down. I'll probably put an A or B for everybody here. So I'm just gonna go ahead and probably do that again, because I know some of you haven't finished everything here yet. So for me to say, oh, you got an F, nah. I know that everything's been self-paced here. So, but again, we're at the midterm point here at this stage. Okay, we are 4 weeks in. So I'll be putting up a midterm grade. If you do see an A or B, again, that's just based on what I saw on the homework and the test, and then just kind of give a general grade based off of that. Okay, so nothing is set in stone until the end of the semester when I add up everything. So I was informed about the owner donates money to anti-LGBTQ organizations. Oh, that's not good. The practice exam factor our grades in my math lab. You'll be taking those out. Yeah. Yes, Brian. Yeah, I will be. Yep. Those will be automatically omitted. However, what will be included are the bonus points you will get for doing those practice exams. Okay. Those practice exams will get you bonus points. That's not a bad thing. So, How many questions gonna be on the is the final gonna be? Boy, I don't know. I don't know. What? 50, 60 maybe? I don't know. I don't know. If I gave you a definitive answer now, yeah, that'd be a lie. So, 20. 20 questions? Really? Whoa. How can I put 20 questions on a final? Oh my gosh. Oh my gosh. You guys are gonna kill me if I give 20 questions on a final. Holy smokes. You can do it. I could, but it would be pretty bad. That's not even a comprehensive final. Yeah, 20 or less. 40 made me sweat. Look, the final has to be sweaty, okay? The final's gonna be sweaty regardless. Alright? Final's gonna be sweaty. That's how it is for finals, alright? However, I will tell you this about the final exam. So at least I can give you some inside info regarding the final. Like I said, transparency is always number one in this class. The way I'm going to make up the final exam will be based on the pool of questions from all the exams put together, and then I'll be narrowing that down into a final exam. So from every single exams, from all 5 exams, I'll take those pool of questions, I'll narrow it down even further from those pool of questions to like 50, 60 problems, something like that, and then that will be the final exam. So that's precisely how I'm going to be making up the final exam at the very least. I can tell you that right off the bat. So you'll know how it's done at the very. So it's 20% in terms of weight. Whatever the weight is, basically whatever is listed on the syllabus. So yeah, was it 200 points out of 890, whatever that is, off the top of my head. So whatever's listed on the syllabus, that's the weight I'm going with. Easiest questions, maybe. Like, you'll know more details once I make up the final for sure. So, but I can tell you how I'll make it up. That's really not a hard thing for me to do. So some expectation for sure. Some expectation for sure. I can tell you that 100% definitively. Off to the DMV. Go grab your ticket. Yes. E1501. E1501. Come to counter 13. E1501. Come to counter 13. Make the final one question. You get it or you don't. Ooh, brutal. That'd be so mean. Oh my god. All right, ladies and gentlemen. Ladies and gentlemen, I want to thank you all for coming on out here to the stream once again. Everybody, thank you so very much. Please enjoy your 4-day weekend. Enjoy your 4th of July weekend, everybody. We're going to be back here on Tuesday, July the 5th, okay? Tuesday, July the 5th. All right? Everyone, thank you so much. I love you all. All of you are absolutely fantastic and outstanding people. All right, again, enjoy your weekend. And as always, ladies and gentlemen, stay safe, stay healthy, but most importantly, stay sane. Have a great barbecue, everybody. Enjoy yourselves. All right, take care, everybody. Happy 4th, and we'll see you on Tuesday. All right, have a great one, everybody. Take care. Bye. Remember, I'm on Discord and email if you need to contact me. All right, take care, everybody. Bye-bye.